Good afternoon, everyone. This is Gretchen Wall, the coordinator of the Produce Safety Alliance. Welcome to today's Produce Safety Educator meeting, which is focused on managing food safety risks while using soil amendments, an overview of new resources. This is Educator's Call number 56. So if you've missed the other 55, they're all posted and available on our website. We have all of the recordings available to you. So do check that out from our website, producesafetyalliance.cornell.edu. And just as a reminder, throughout the presentation, we will keep everybody on mute, but there will be some time for questions and discussions at the end of the meeting. You can also use the chat functionality, and we'll try to get around to all of the questions that come through in the chat. If not, we'll try to follow up with you afterwards. As you can see on your screen, we are recording this meeting. And like I said, we archive all of these meetings and the recordings on our website. If you go to the drop down on our website under resources, there's a whole tab that says Produce Safety Educators Calls. You can find them all linked there, and they're available on our YouTube page. Just as a quick notification for our next series, we are not going to have a call in September, and we're still working out some details for our meeting in October. So we'll follow up with you through the listserv and post that on our website as soon as we know what date and the specific topic. If you ever have any specific topics or speakers or areas that you'd like us to focus on through this group, please do let us know. We always welcome suggestions. You can email me at glw53@cornell.edu or email any one of the other PSA team members. We're always happy to take your ideas. So with that, I'm going to turn it over to Dr. Elizabeth Bihn, who's the director of the Produce Safety Alliance, to do some introductions for this afternoon's presentations. Betsy?
Thanks so much, Gretchen. It's my pleasure to introduce Alda Pires, who will be presenting the first talk for today's Educators Call. It's going to be Alda and I today. She's going to go first. I'm going to go second. Alda is an associate specialist in the cooperative extension at the University of California. She is the lead PI in the multi-regional risk analysis of farm manure use, which is a USDA Organic Agricultural Research and Extension Initiative funded project. This was a multi-year, multi-state project, and Alda has been doing all of the cat herding from the very beginning, and she's done a great job. It's been great working with her, and I'm super happy she was willing to join us when we had to slightly modify what we were going to do today. So she's going to tell you about the research and what's gone on, and I'm going to follow up with a talk about some extension materials that have been developed. And without further ado, Alda, you can take it away.
Thank you, Betsy, for the presentation. Introductions. Everyone can see my slides. Is it okay?
Yeah, there you go. Perfect.
Okay. Okay, thank you, Betsy, for introduction. And as Betsy mentioned, this has been a team effort and a multi-year project, work with different institutions, looking at the food safety risks using soil amendments. In this case was untreated manure, and assess what are the risks for use of untreated manure on certified organic farms. And we know that organic farmers use biological soil amendments of animal origin, manure and compost to improve soil fertility. So there are many advantages, and they depending on those biological soil amendments as the use of chemical fertilizers are restricted. And this multi-state project actually started with a needs assessment, a planning grant before this 5-year project. And that needs assessment, we're interested to know what were the practice that certified organic farmers are having regarding the use of biological soil amendments. And it was unanimous for those participants, farmers, that was very important to use biological soil amendments contain animal manure because of soil health, nutrient management, soil tilt cost, and animal waste management. We observe a regional difference between the participants on this survey using treated manure or compost between the West and Midwest and Northeast. So there was regional difference on those practices. although we saw that most of the topic sources in terms of livestock were poultry, cattle, and horses. So this project actually lead us to this multi-state on-farm study. So we know that use of biological soil amendments on manure, they are risks, especially for those that not be treated to reduce those pathogens, as the livestock and poultry are natural reservoirs for E. coli on 5.7, Salmonella, and Listeria, and so on. So the prevention to avoid the microbial contamination of vegetable crops in this case is based on time interval between application and harvest. And the certified organic farmers, they follow National Organic Program standards that will based on time interval 90 days or 120 days between the application of incorporation of that untreated manure and harvest of the vegetables, depending on they are or not in contact with soil. So, and the research and other studies has been done, we know there is a multitude of factors that affect the survival of those pathogens either on manure or in soil. And this graph or this diagram, it simplifies in different main groups as factors inherent to the soil, as soil characteristics, moisture levels, nutrient availability, and so on. Management practice related with agriculture, land use, irrigation water as the source, the storage, and the pathogen load. So there's different factors besides the manure itself, the source, the pathogens in the manure. So we're interested how these factors play a role together on these systems, certified organic farms. And that leads this, as Betsy mentioned, a multi-state project. So we're conducting on-farm research in California, Minnesota, Maryland, and Maine. And this was not on the research fields, they actually commercial farmers that collaborate with us, and was on 19 USDA certified organic farms. So we're able to follow up those farms during 2 growing seasons, and was a longitudinal study, meaning we're following the same soil and the same plots over up to 150 days, 180 days. So here on this diagram on top, it simplifies our sampling scheme. So we want to see how foodborne pathogens persist in the soil after application of untreated manure, that was day 0B, and monthly we test the same soil and test for the main foodborne pathogens, E. coli on 5.7, STEC, Listeria, and Salmonella. And because these pathogens are rare in the soil, in farm environments normally, we did also monitor for generic E. coli and assess the concentration. So there was a longitudinal follow the same plots in each growing season and to test for different foodborne pathogens. And here there was, we have target 3 main sources of manure. Was farms that are using horse, cattle, and poultry. Some they use also small ruminants. And with this picture, just to show how diverse was this type of manure. Initially thought, it's in fresh manure, but the reality, the fresh or the type of manure used by these farms, it depends a lot. So on first picture, we have horse manure coming out from the barn, the boarding barn, where the farmer is using their manure. On the middle, have duck manure from duck farms. They were there in storage for some time on the farm. And here is another smaller farm, we use goat manure. They have different age, and actually the way they are stored on the farm varies greatly across the farms. So what were those implications in terms of contamination of those manure, or how much pathogens we found? Numerically, we found a difference in terms of age. So we saw there was a prevalence of those pathogens variable depending on the age. Also, we saw that some types of manure is not new, were higher positive for different pathogens, for example, small ruminants for STEC. And it was not a big surprise, because we know that certain animals, as cattle are reservoirs for STEC or Ecoline 5.7, while some are for poultry. So there was a diverse types of source of manure that reflect in terms of age of manure that was used on the farm, and then reflect in terms numerical in the final risk analysis. It was not significant, but in terms of numerical, there was a difference in terms of positive of samples for different pathogens, depending on the source and of the age of the manure. So one of the parts of this studies, it was, as I mentioned before, was looking at how we're able to detect those pathogens in natural conditions on those farms applied manure. So I'll present here two graphs, and the first one is the prevalence of STEC in the soil, meaning this is not the concentration, it's not the load, but the number of positive samples we're able to detect in the soil by time. So 0A was baseline before the manure was had, and then every 30 days or so until 150, 180 days. So there was a quite number of soil samples. The total study was about 2,500 soil samples. So what we observed was after incorporation heading manure, we saw an increase of the prevalence of those pathogens in the soil, in this case of STEC. And then at 90 days, there would go down levels lower than or identical levels as the pre-application. Interesting with STEC, we saw a spike after 120 and 150 days, specific for STEC on proportion positive samples. While for Listeria, this is the same graph, just changed the pathogen, was Listeria monocytogenes. While for Listeria, we saw an increase of prevalence after the application, incorporation of manure, but 60 days, we saw very low levels and actually lower than that were detected baseline at 19 on 20 days. So basically these two graphs want to show is this not this perfect die-off that we normally see on those application or inoculation studies we see. There is variations by time, but in general, we decrease the levels of pathogens below the baseline or around baseline by 90, 120 days. So this was what relating to the NEOP, we're interested to know, are we able to detect those pathogens after 90 and 20 days? Yes. And then the next question was, what are the management practice and factors in the environment that may affect our ability to detect those pathogens in the soil? And here, next slide, I have a group by main groups of manure management, agricultural practice, and so on. On bold is actually, in bold is the pathogens we found significant on our study. So for example, we know that a different practice in terms of was the presence of pathogens in manure higher risk to identify in the soil. Yeah, that was true for Listeria, not for STEC. The application method also has a role. Actually, those farms using disking rototilling was less likely to find pathogens in the soil along the time. And the application season was less consistent among the different pathogens. Although there is another factors we're not able to detect a difference in our study, we know it does affect the ability of survival of those foodborne pathogens in the soil is application rate, livestock, treatment, and key composition characteristics of manure itself. We didn't find in our study, but it's well described in literature. Other things was considered is the storage and proximity to the fields and runoff, and it's something important when we're assessing the risk on-farm risk assessments and on-farm inspection. And here I bring a few pictures of different piles of aged manure. Some of the farmers we might call compost. So it's not uncommon to see a pile that's minimal manipulate, I'll say, and they let that pile in the farm for a couple of months. So sometimes we come across it. This was a pile on the left side of mostly was poultry litter, although we can see that the farm is having other sources, vegetables, actually see some carcass, poultry carcass as well. So what are the risks of these kind of continuous piles of manure? We didn't find any significant change in terms of age, but something to consider that may bring different risks when have different sources or different materials heading to that manure pile. Another example here on the right is what is storage, or are those piles? Are they close to the fields? Is there close where there's maybe potential risk for runoff of those manure piles? Again, this is a commercial farm where we see some water accumulation around the piles. Actually, here they were very well separated from the fresh produced fields. So that's another terms of management practice of manure that may bring additional risks to the potential contamination of the field of fresh produce. In terms of agricultural practice, what we saw consistently in this study was the previous use for livestock of the field, that was used for livestock for different reasons, or presence of fecal material on the field increased the risk for us ability to find STEC and Listeria monocytogenes in the soil for presence or previous use for the use of the field, and the fecal feces for STEC only. And here I bring two examples of farms. Some of these small, medium farms, they might integrate livestock in their production system. And here was a farm, they actually have these poultry mobile coops where they move the animals along of the cover crops of vegetable production. So assessing what these risks of these systems is important, and what's the proximity of the vegetables fields in terms of potential contamination. In terms of irrigation water, we're able to identify the source. So those farms, there was significant associated with Listeria, not STEC. So the source for those farms, they use more than one type of source of water as surface water and well water. They were at higher risk. Although all other factors have been seen is the contamination load on the water. We didn't find any pathogens in the water in these test farms. And also irrigation type, for example, the drip systems compared to overhead is well described. Most of our farms here in California, they use drip lines, but in other states, they use overhead or sprinklers. We didn't find a significant difference between those farms studied, but it's well described, the risk in other literature. We're very interested in the crop type. It doesn't matter if you have leafy greens or have a root vegetable. We know that the conditions in the soil will be different. We didn't find a difference between the crop type that was in the plots, but there's some studies out there that shows the difference between the crop types, special type of crops they are planted before. Other factors that you might have less inherent to the soil was the soil moisture, organic matter, the composition, and as well generic E. coli. Interesting. So I mentioned that in the initial that we not test just for foodborne pathogens, but also for generic E. coli. So the concentration of generic E. coli was significant associated with our ability to find Listeria, but not to STEC. So, and there are other factors I were able to capture because it was a multi-state and different geographical areas was meteorological factors. So we saw that a difference between years, that's why important to conduct these on-farm studies over different growing seasons. So there was less likely to find pathogens on second year. The sampling day was significantly lower for STEC at 60 days and for Listeria from 30 to 150 days post-manure application. These comparing with baseline pre-application of manure. And another weather-related factors was snowfall, temperature, and so on. So these are kind of factors we have less control, right? Environmental factors, but when you come, this is a farm we sample later in the fall in season, and it was right after raining season. So assessing those potential events or be aware of those potential events that increase the risk of contamination is important for the farmer to make decisions should they harvest or not the field and potential contamination of some of those periods with heavy rainfall. So you may ask, so about the soil, we talk about the soil, did you find pathogens in the produce? So the risk is cross-contamination. So we did sample produce across the farms between 60 to 150 days, and we only found 2 samples. It's 0.4% of the sample, the produced samples that were positive for Listeria. Interesting one was from a plot, they didn't apply manure at 90 days, and another sample was applied cattle manure. We didn't match these isolates with the soil and the manure, so we cannot tell if those actually from the source of manure. What we can tell is pretty rare or infrequent to find pathogens in produce in this study. All the samples were negative for another pathogens. So summarize, and I think the importance of this type of on-farm studies to have overview picture, what are the factors that were associated with our ability to find pathogens in the soil, and they were factors that we probably management-wise we can have control or can improve as related to manure, irrigation type, land use. But there are many other factors that are less able as a farmer, and we have less able to have a control as environmental factors, as the weather related, the characteristics of the soil, and so on. And how is this important? So in this study, we are able to provide to the farmers a risk assessment tool. So based on their practices on farm, how they are at higher or lower risk compared to other farms in terms of identify foodborne pathogens in their soil, and also able to make some recommendations for mitigation practice. So as Betsy mentioned, this is a multi-state and integrate project. So we have the research and then the outreach extension that Betsy and Donna have been working, and then she will give us an overview of that modules in terms of outreach materials. With that, I would like to thank you to all my collaborators, different agencies or institutions, and the funding agency for funding and the producers participants in this project. And that's all I have for today's presentation. Happy to take any questions. I think we will taking the questions at the end of the 2 talks.
Yeah, thank you, Alda. If anybody does have a pressing question now, we do have a few minutes while we transition over the slides, and we'd be happy to humor that. You can raise your hands or put it in the chat box. Oops. Of course, this is what happens. Anyone? Okay. Hopefully you all can see my slides, because I can go to the next part. Oh, we do have, let me see. Nope. There is a question, Alda. Do you have a sense of why the STEC levels increased in the soil at 150 and 180 days after application of manure?
That's very interesting, and we can there's few potential reasons. One thing is some of these fields actually they were waiting for us at 150, 180 days to do the soil samples. They are not harvesting the products. They already end of the season. So I'm wondering if that is because they are not harvesting it. There's some contamination from other sources as wildlife. Another part is we saw, so this is not cause effect. In this type of studies we saw association. We cannot tell that was because of presence of fecal material on the fields, but that indicates is a risk factor. So I'm wondering for those late sampling points was a more intrusion of wildlife and other animals. We did observe association on univariate analysis across all these 2 pathogens, but when we did the multi, just for one of the pathogens. So there is some evidence it might be another sources of contamination in summary.
Okay, super. Can you define DOA and DOB? I assume the former is date of application.
Oh, yeah, so my fault. So DOI was days baseline, days before application. So we did a baseline for all the soil to understand what's the soil. There was some pathogens there, about 5% for both. And 0B was after application of manure and incorporation. And what did that, it was between, could be between 2 days to 1 week after application of manure and incorporation. Most of the farms are using rototilling and disking. There's some other ways of incorporation. That's yeah.
Okay. And then the last one, were the soil amendments tested for pathogens before it was applied to the soil to compare results after 90 and 120 days?
Yes, so actually we test, so some of these farms, they use manure and compost. So we did test both. So we tested manure and compost for pathogens, and overall in manure across all species was about 12% of those samples were positive for one type of pathogens. And the compost, I don't have now on top of my mind, but was a lower percentage. We find some of those. I did not present the data for Salmonella and E. coli 157. And the reason is because we found, although we found those in the manure, we found a very small percentage in the soil. So by 30 days in Salmonella, we didn't find any Salmonella in the soil. And E. coli 157 was very specific for one farm. Another thing I didn't mention here that's interesting, when you see, I present two curves, one blue and one red, and I didn't go in detail. What that means was when you adjust that proportion of positive samples by time for farm, we see that was a higher cluster on farm. So what is telling us there was higher number of positive samples for some of these pathogens we did farm. What is telling us is there's something specific on that farm that year that we found more pathogens on that farm. So, and you know, what is specific about that, it probably could be the source and different factors we identify as significant.
Super.
Yeah.
Thanks, Alda. That's all of them. And thank you all for the questions for Alda. That was great. Hopefully you can see my slides now. And what I want to say here is I really appreciate Alda sharing the update on the research program. I think that's really important and highlights some interesting outcomes. They're still doing data analysis on that. Donna and I have been working on the extension component, as Alda mentioned, but Donna has really been the lead on that. And had her little boy decided not to show up a few weeks early, Donna would be presenting this presentation. But since she's out on maternity leave, I put together some slides for this portion to really highlight what we've been doing on the extension side of things. So that's really what I'm going to focus on today. So the focus of these modules is really a result of the OERI grant deliverables. We have, Donna was the main presenter, done 2 webinars with the Organic Center. Those are available. I put the link up here, and I'm sure somebody will post it in the chat box as well. But if you want to see the modules as they're developing, you can watch those recordings. We are focused on areas to reduce risk and develop information where growers have questions. Alda did a great job of showing you some of the things, and I'll try to highlight them as I go along. We did include some produce safety rule and some National Organic Program information in the slides, but it was not the sole focus of the modules. So sometimes when you think about the Produce Safety Alliance and some of the work that we've done really focused on the produce safety rule, these modules go outside of just the PSR stuff and the NOP stuff. So it weaves it all together, which is, I think, really what brings value to some of these modules. I wanted to start by showing you this slide that we developed really when we were presenting the other 2 modules back to back. But this slide sort of gives you a feeling for this broader topic of soil amendments as defined, meaning any chemical, biological, or physical material applied to the soil, intentionally added to the soil to improve those chemical and physical conditions as it relates to plant growth. Now we know the produce safety rule gave us biological soil amendments of animal origin, and then it broke it out into sort of other soil amendments that are not BSAAOs or biological soil amendments of animal origin. And so these two modules sort of focus on that blue and orange box that you see on the slide with the untreated and the treated. As Alda mentioned, the research on those raw applications, what happens, we also wanted to include in the outreach ways you can reduce risk. So that really got us focused on the other module for treatment. So what I'm going to do for the rest of the presentation is really give you a highlight of these two modules that were developed, show you some slides that are in there, and talk about ways in which they can be used in an extension program. So the first module is this managing soil amendments for food safety and soil health. We may modify the title a little bit, but this one really is trying to show you that we're going beyond food safety concerns here to talk about soil health. It's important to look at the farm as a whole, both the risks and the benefits. And so that's that first module kind of focused on things beyond just the risks. How do we use these? How does it improve soil health? What are other things you get out of it? And I do want to mention, and I'll show you a few slides here about aged manure use. Alda mentioned that one picture where you saw that they had the squash mixed in with what was chicken litter mostly. So what are growers doing with that aged kind of thing where they're not true composting? And rotational grazing. Again, Alda had a great picture of that mobile chicken coop. So those kind of things that are going on with growers. The other module is science-based composting practices. So trying to bring a little more information to how do we reduce risks? Identify those differences between untreated and treated. Again, going back to that idea, is aged treated? No, aged isn't treated, it's just aged. We're clearly using terms from the produce safety rule here, biological soil amendments of animal origin, treated, untreated, but trying to keep the focus on the full farm. I see this as one of the clear benefits of these modules is incorporating and defining these terms, but not having the regulatory requirements as the sole focus. So hopefully that's a good introduction to sort of these two modules and what they're focused on. Now what I'd like to do is give you sort of a sneak peek, more of a highlight reel of some of the things and highlight why I think these slides are good, what they do, how they can be used. So this is a great example of how the slides incorporate foundational knowledge in the modules. And it really is aimed at getting everybody who might be participating in your presentation if you use these slides on the same page. So this slide you can see define soil amendments, making sure people understand chemical, biological, or physical material that's added to the soil to improve the condition of the soil. And then it starts to focus on, okay, we're really going to talk about the biological soil amendments of animal origin, since that one is the one that's specifically highlighted as bringing microbial risks in addition to those soil benefits. Okay, so again, an example of one of the slides that talks about foundational information and definitions. There's also a slide to highlight going beyond that food safety risks. What are the benefits? Why do people use biological soil amendments of animal origin? And again, I think it's really, really important for growers that aren't subject to the rule that we be thinking about why folks are using biological soil amendments of animal origin. And one of the really marvelous things we get to do working with Alda and working with the group that did the research was we also get to incorporate data from what they've done. And this is one of the slides. Alda showed you, her slide was, you probably couldn't see some of the details. It was one of the first slides she had in her presentation. But they did a survey and 58% of growers surveyed said they were using raw manure. 74% did not treat prior to applying to the fields. So they may not be eliminating manure in favor of compost due to cost, transportation, labor, and other barriers. they talked about these following reasons of why they're using biological soil amendments of animal origin: improving soil health, nutrient management, improving soil tilth, cost, right? Getting that valuable manure as a soil amendment, and waste management. So this is one of the fabulous things about these two modules, is working with that OERI research group to incorporate up-to-date data about how growers are using these materials and the results of the research. Another cool set of slides, I really like these two next slides coming up, are an example of trying to clarify how NOP and the produce safety rule intersect. In some ways, these are very subtle, and you'll notice on this slide and on the next one, we pulled out some quotes, right? We often use the 90, 120 day application, and people will say, you know, I use that. But we wanted to stress here that there's a quote from the preamble to the Organic Foods Production Act that says, "We have consistently maintained that NOP is for marketing, not food safety purposes." But there is clear science data that indicates that pathogens do reduce over time. Alda just showed you some more data on that, but that they also can persist in soils beyond these timeframes. And again, Alda showed you they even get some increase over time. So using days to reduce risks is really important. If you're an organic grower, you're following NOP, you're going to be using those standards. But it's important to understand that those standards may not be there specifically for the issue of food safety. I add to that, though, a quote in this slide from the Produce Safety Rule Guidance document that talks about adhering to the 90 and 120 day application interval if you're following NOP, or even a grower who's not following NOP, to be a prudent step towards minimizing the likelihood of contamination while the risk assessment and further research occur. So this is one of the opportunities we took in these two modules to talk about NOP, to talk about PSR, and bring about some of these discussions. And I think it's a really valuable part of the slide set. It is always important to ask growers to consider their own farming practices. As with all our extension and outreach, we're trying to provide growers with information so they can make science-based decisions at the farm level. And that's always a goal. And so we've included slides like this one that help growers think through, okay, what kind of biological soil amendment are you using? Alda mentioned all those different kinds. She had that beautiful picture with all the different kinds of soil amendments that folks are using. How is it stored? Where is it stored? When is it applied? What's the environment? I thought it was great that Alda talked about growers can't control the amount of rainfall they're getting. So what are the factors you can control versus the factors you can't control? And certainly this last bullet point, talking about sanitation of tools, is really important. These modules gave us an opportunity, I mentioned earlier, to explore things like rotational grazing and aged manure. And so that first module is really focused on these things. So I'm going to transition to some highlights of the second module, talking about treated biological soil amendments of animal origin, and specifically focusing on composting. And again, we have foundational slides. This one is on the process of composting, trying to get everybody who's listening to the module on the same page about how composting works, where, you know, what are the temperatures, how are everything affected by that. The other opportunity we used in this module was to talk about specific kinds of composting. Within the PSR, it talks about composting systems, but many people are unfamiliar with them. In the Produce Safety Alliance grower training, we mention what is mentioned in the Produce Safety Rule, but we don't provide a lot of details. This module allowed for more details to be shared and to improve overall understanding of these different types of systems. There's just, these two slides are just a highlight of the two systems that are highlighted, but there's more slides in the module that talk more in depth about each of these types of composting systems. We also had the opportunity to talk about things like curing. And curing is something that there's a lot of questions about. Prior to presenting the modules with the Organic Center, people submitted questions that they had, and curing showed up quite a bit. It's a difficult thing to understand, it's difficult to achieve, and so this is one of those areas where it was a great opportunity to bring more clarity and to help growers understand what's going on with curing, how you know if you've reached it, how to get it done. There's another slide in the slide set that talks about ways to get this done on farm. In addition to talking about curing and other ways to know if your compost is mature, this module includes ways to test maturity, including traditional germination test, as is highlighted in this slide, as well as things like the Solvita Compost Maturity Index. These are ways growers can figure out if their compost has reached maturity. As with the first module, where we talked about things like aged manure and rotational grazing, this module gave us an opportunity to talk about other ways to treat manure, such as vermicompost. We've been getting a lot of questions about vermicompost recently. On the way to the office today, on the local radio station, the state of New York is talking about not allowing food scraps in landfills. And there's quite a few vermicompost setups in upstate New York. And I know this is not the only state that is moving in this direction. So it was a great opportunity for us to include vermicompost in here. There is still lots of research going on with vermicompost. We're doing some research here at Cornell. I know Dave Ingram's group down with FDA has a lot of research going on with vermicompost. So it's good to get the conversation started and include that information in this module. So what are the plans for the module? That really wraps up sort of the highlight reel because we wanted to leave some time for questions today. But our plans for the module are to incorporate additional data that's coming out of the OERI analysis that's going on. We want to incorporate feedback from a post-webinar survey. The survey that we did with the Organic Center, we did have a survey, post-survey that growers responded to. So we want to take that information and feedback and modify the slides a little bit. We want to add teaching notes. Gretchen was telling me when I asked her to review these slides that she's like, I can't really tell what that picture on slide 23 is about. It really was what I was trying to highlight was like the PSA slides, we intend to give you detailed slide notes so that if you want to use the modules, you'll have slide notes there and information and references and resources so that you can actually use them functionally. We want to make the modules available either in late 2021 or 2022 for winter and off-season grower trainings in early 2022. In terms of extension options, I think you can use the modules independently to conduct trainings with growers. I know sometimes on winter programs, people are looking for, a good 45-minute, half an hour presentation or hour presentation. You can combine the modules for a short workshop. You could incorporate hands-on activities, some compost maturity test, or, the PSA has the, is this a biological soil amendment of animal origin activity? Or you can use parts of the modules to enhance other trainings. I certainly think there's things in here that I would probably weave into other presentations to make them more effective. But the point is they're meant to be used. They were created to provide people with more information. So we're really hoping people will find them interesting and be interested in using them. With that, I know Alda mentioned everyone involved by name. This is our slide just to recognize the work that was done with Alda in the lead, and it was great to be a participant in that group. And there's a website, the Produce Safety Alliance website, and I will take any questions. All right. It might be helpful to add that they want to avoid piling manure over 7 to 8 feet as it can spontaneously combust. I've actually seen many piles on fire. I have never seen a manure fire. How is that possible? Thank you, Kristen, for that. I don't know if there's any other questions. Thanks for the chat. Mike, he said he's incorporated his own slides in situations shown in the modules and research. You can also ask questions of Alda if you don't have any questions for me. I know there were several. So I went kind of fast because I wanted to make sure we had time at the end for additional questions. Thanks, Kristen. FDA and MSU Extension are working on biological soil amendments of animal origin videos that can be incorporated. Good advice. Don't roast marshmallows over a compost pile. Heather asked the question, Alda, and I'll let you take it in the chat box. I know the answer, but I'll let you take it. Will the results of the first study be published anywhere?
So the first study of needs assessment, actually they are published. That includes a regional survey and listening sessions, and we can make available. So those are published and out there. The findings of the first data I present, they are under revision, and we are targeting open access journals. So everyone will have access to this data and the findings. So we're working on that. And there's a question, anything you were most surprised by when doing the research?
I think there were a lot of surprising things in the research. Sorry, go ahead, Alda.
I think something was surprise, and we don't have a total explanation, was those peaks at 120, 180, because we haven't done any DNA fingerprinting to see how related are the isolates for this project. So it was a surprise for STEC. Another thing was not a surprise, but a confirmation, is each farm, these are relatively small scale, medium-sized farms. So it might not be those organic big farms producers, because in terms of, they use mostly of compost. What I learned from this work was each farm is its own case. They have very particular practices, and I think that comes how important is the on-farm risk assessments for these farms and mitigation, reduce the risks. Because I visit all the farms in California, I didn't visit one in other states, but what I could see is the practice are very different from within the state and the region and between states, and how unique are those farms. And I think that's one of the challenge. One side of the farmers, they want us to tell them, give me a number, give me a thing to fix the problem. And that's, could be the time interval, but we know it's much more complex than that. So it's not a surprise, just a confirmation, but highlights how important is on-farm risk assessments and evaluate the risks. They might change over the year too, as we know. I don't know, Betsy, do you have anything to add to it?
Yeah, and I think this is why we incorporated that slide in the outreach, talking, constantly encouraging them to think about their own farm. Because it is, when you get to the individual farm level, what they're doing does have an influence, and trying to give them information to help them make those decisions about risk assessment, about putting into practices. I think some of the meteorological influence data sort of surprised me, or at least it was really interesting to see the influence of some of those things. To me, was some of the interesting parts of some of the data that I saw. I don't know if you agree with that, but I think that idea that you can't control what's going on in your area from a meteorological standpoint, but it does impact pathogen survival and changes from year to year on an individual farm.
Definitely. So just 2017 was a much wet year actually. So across most of the states, and I think that's part of we saw that change, that difference year to year, and that reflects the type of data collect on soil moisture affecting the ability to find those pathogens in the soil.
Right. It's not, it's a very complex situation. I think the good news is some of the post-harvest, or I mean, some of the product work you did looking at pathogens, was that some of that data was interesting as well. So it can be out there, but it doesn't necessarily mean it's going to get on the product. And I think that's the other thing growers need to think about, is prevention of cross-contamination, right? How do you protect the crop if it's in the soil and stuff like that? So I think those are big outcomes.
So one question is, these are sites where the research done affect different growing location practices. So we try to, in our inclusion criteria, doing that, the different sources of type of manure use and locations here, at least here in California and other states, although was certain difficult to find, people enrolled for such long study in these type of farms. So I'll say, next question is this, what these findings apply to all other types of farming? Not necessarily, because they are very specific. We try to get also geographical, because we know the soils are different here and in other states. We try our best. This reflects what other farms are doing, not necessarily, but I think we got a good representation of some of these small, medium-sized farms. They are using untreated or aged manure.
Any other questions? Oh, there's a Q&A. Sorry, How many new slides are there in this module? Can individuals who have already gone through the PSA grower training sit in on the train the trainer course once this module is approved and ready to be used? Okay, so this is not going to be a PSA module, just to be clear about this. These will be modules that will be available. This is different than the Produce Safety Alliance stuff. So we will just put these modules out, and people will be allowed to use these modules however they see fit. Hopefully that's the answer to that question. How many slides are in each module? Let me quick tell you how many are in them now. But then I also want to say that that is subject to change, because we're probably going to add slides as we get more data analysis. So currently in the science-based composting module, there are 30 slides. And in the manure one, there are 27, but we will likely add a few more slides as we incorporate some new data from OERI as they get through their analysis. Where will we be able to find the slides and the files? Alda, do you have a website that you're going to put all the OERI data on? Otherwise, put them somewhere on probably the National Gaps program or other places, Organic Center?
So we have a dedicated website with our partner, the Organic Center, and also on my webpage, we will post it. I mean, and any other place that, you know, don't know, Betsy, find fit, good place. But we have a dedicated Organic Center for this project, and Granch already, she did share the link. They'll be there too as well.
Mm-hmm. This research was not funded by CPS, I don't believe. It was USDA OERI.
Yes, it was all the research was funded by USDA OERI, both projects.
Other questions? All right. Well, we are in the 4 minutes. If there's no questions, I don't think we have a slide about this, but we decided on team meeting this morning that we're going to go ahead and skip the educators call for September, and we're going to regroup and have a call in October. We will get that information out to you as soon as we have a speaker set up. Oh, and yes, we also want to remind all of you that the Produce Safety Alliance has the Northwest Regional Extension Associate position open. Hopefully somebody can post that in the chat box for me. That is a position that was held by Connie Fisk, who is now at the Washington State Department of Ag. And we would love to have somebody that is the quality of Connie join our team. So if you have any colleagues that you know that would be spectacular for the job, please ask them to apply. Thank you, Gretchen, for posting that in the chat box. And we that position is open for 4 more weeks. It will close September 13th. So please, please, please share that with your colleagues, or if you're interested in the position, please apply. If you're not sure if you want to apply because you don't know really what the PSA Regional Extension Associates do, give us a call or give one of the Regional Extension Associates a call and talk to them and ask them what they do. Or you can call me. I'm happy to talk to you about it as well. But they're going to be able to give you a much better idea of day-to-day, how they spend their time, and what it's like working for the team. Or you can contact Connie Fisk, since she used to be in the position she just offered. Thank you, Connie, so much for putting that in the chat box. And she'll be honest, because she's got nothing to lose. But if anybody else, if you know anybody, please do. We would love to have a good applicant from the Northwest. And we're hoping to start those interviews in mid-September when we close that position. Anything else from the team or from the group?
Louisa may have a question. So
Louisa, you got a question?
Made a mistake.
She made a mistake. I didn't really read it.
Connie.
Trying to find the laugh out loud emoji when you mentioned Connie being able to give a first hand. I thought that was good.
That's right. That's right. You got to trust somebody who left the program, man. I do want to, before we go, I really want to thank Alda for joining us today and for doing such a great job and fielding all the questions. Again, we were a little surprised by Bo's early arrival, but I'm super happy Alda could join us and that we could share with you guys what's been going on with the OERI project. Alda did a great job of organizing that and keeping that moving forward over several years, and it was great to be a part of it. So thank you, Alda, for joining and your leadership on that project. With that, yeah. Gretchen, is there anything I'm forgetting? Oh, there's the educators call recording. It'll be posted. Thank you. If nobody has anything else to say, I'll just say thank you to everyone. Thanks to Gretchen for running the show behind the scenes today. And have a good Monday.
Thanks, everyone. Have a good one.